Hello, welcome to Bioinformatics. My name is Jeff Damath, and I'm the professor for this course. In this short introductory video, I just want to accomplish three main things. So I'll give you a brief overview of the course content and the design. We'll talk about the logistics of how the course is laid out and what you need to be successful in the course. And then last, I'll point out the first steps to get you going. Since everything you need for the course can be found in Canvas, let's go ahead and jump over there. I'll start sharing my screen. When you enter this course on Canvas, you should land on this page. And so when you get here, right, it says if you're here for the first time, you are already doing this first step. This is the introductory video. The link is here. I'll apologize in advance for the ads on YouTube. I am not monetizing this through YouTube. The upside of using YouTube is that it lets me put in the chapter markers. And so that's why I've kind of moved all the content, all the video content over to YouTube, despite the ads. And I know they can be annoying, but I think the benefit outweighs having to listen to an ad once in a while. So the next thing there is to read the syllabus, but I'm not going to do that. I'll let you do that on your own time. And we're going to hit most of the important information that's in the syllabus when we go through that Getting Started module. So clicking that link to get the Getting Started module will take you to this content module page. And you will probably only see the first two content modules. As the semester progresses, I'll be publishing the new modules a week or two before we're scheduled to get to them in the course. So that's just in case any of the software or the compute resources that we're going to be using go down or they change versions significantly. And that way it allows me to be making adjustments that we need to the module before you all run into a problem. Since bioinformatics is a really rapidly evolving field, there's almost always versioning challenges. And to some extent, learning to deal with those are part of becoming a bioinformatician. So they're useful educational parts of the course. But at least for the first part, I'm going to try to keep those to a minimum. And so I don't just shoot all the modules out there at the beginning. So like you can see, I've got all these modules, but you're only able to access the ones that basically the ones that I know work. And you know, it's not uncommon, even over the course of a semester, for some major updates to come to some of the software that we'll be using. Or, for example, in this third module, right, we'll be using the high performance computing infrastructure in Pittsburgh, and that's completely out of my control. And so if there's anything new with credentialing or things like that, I need to make those adjustments to the module before we get there, before I let you guys get there. Okay, so back to the Getting Started module. This first page in the module is all about me and your GTAs. So I'm Jeff Damath. I'm an associate professor in biology and the associate chair of the department. If you want to know what my lab does, good place, at least to see what we've been publishing lately, is to go to my Google Scholar profile. That's the most up-to-date information. You can also get it on my faculty profile, but sometimes that's, you know, I don't maintain that as much. Google Scholar is automatically maintained. My office is in ERB 430, and I will have office hours on Friday from 11 to 1. And those office hours by default will be online via Teams. I'll open up a Teams video link if people want to meet by video or without video. You don't have to have your camera on. That's fine. And I'll also be available on Teams to answer in the chat. And a lot of students prefer to use that avenue anyway, and it's just that way convenient for both of us. That said, if you want to have in-person meetings, happy to do that. More than happy to do that. I love getting to know all of the students in the course. whether you're in an online section or in-person section. Just email me and we'll set up a mutually convenient time to go ahead and meet in my office. There's my email. That is my preferred mode of communication. Messages tend to get lost in Teams. If I don't get back to you quickly, especially about a logistical type of question, go ahead and don't feel like you're bugging me. You can send me another message and remind me. That said, if you've got content-related questions, I just want to set up an expectation here that you shouldn't expect me or the GTAs to be really addressing the content questions outside of office hours. And the reason I want to set that expectation up is that there are a lot of students, and we could spend, 12 hours a day, every day, just answering individual questions. So by setting up this expectation, I'm trying to sort of concentrate the efforts, and we will often respond more quickly. I just want there to be an expectation that we are not on call 24/7. Your GTAs, Adam and Zoe, are PhD candidates in biology. Their offices are also over in ERB. And we've set it up so basically any day of the week, you should be able to get one of us over that sort of lunchtime, 11 to 12-ish time period, right? So Adam will be available on Tuesday, Thursday. Zoe will be available Monday, Wednesday, and I am available on Friday. So that's us. The next page in getting started will bring you to the description of the course content. So this course is meant to be very hands-on introduction to bioinformatics and computational genomics, especially. The course is geared towards students who have a biology background and limited or no programming experience. And over the last few years, there have been more and more data science people and bioengineering who often have more computational background than some of the biology students. So as we get into looking at the course materials, I'll show the course schedule in a minute. You'll see that the first 2/3 of the class deal a lot with learning to program, being able to function in a Unix environment and then code in Python. You may find that part easy. Then the latter part of the course, when we get into the biology and transcriptomics and genomics, the biology students tend to have a little more background in the conceptual part. And so things tend to be to flip at that point in terms of what people are most comfortable with and which part of the course they're having to do the most learning. And so all that to say that hopefully this is a good learning experience for people who come to it from a computational background and people who are coming to it from a biology background. The learning outcomes, right, just to boil them down into three very broad categories, that you'll be able to solve computational problems by programming in Linux and Python. Second, that you'll deconstruct challenges in molecular genetics into computationally tractable questions and implement computational algorithms to answer those questions. And then finally, to analyze and interpret genome and transcriptome data using both local and remote computing resources. There's no textbook for the course. Everything you need will be made available via Canvas or some other online resources that we'll use. The assignments, there are 24 coding assignments. One of those is a quiz, so you're not actually doing coding for that one. And then there are 23 what I call ROSALIND. ROSALIND is the name of the online homework platform that we'll be using, and I'll introduce that more in a minute. Each of those assignments is worth 5 points, so there's about a third of your grade in the coding homework. There's a midterm that comes up right at the end of the homework. section of the course. So about 10% of your grade there. Once we're through all the coding, we'll get into the computational genomics part. This is where I said the sort of who's being challenged the most, the computational or the biologists will sort of flip at this point. About 30% of your grade will be in 3 to 5 of those computational genomics and transcriptomics assignments. And then finally, there is a final project that will have an analysis, a written, and a presentation portion that's worth about a third of your grade. A lot more information about all of these will come up in the individual modules when they become relevant. Okay. Sometime around spring break, we'll be finishing up the coding homework, moving into the computational genomics, and then I will also introduce final projects either right before or right after spring break so that you can be working on those for roughly the last month or so of the course. You probably have lots of questions about that. You can email me, but just rest assured that there'll be lots more very detailed information about what the expectations are, what the assignments are, as those become relevant in the various modules. Okay. The sections. So there are 3 sections this spring. 2 of them are in person on campus, the undergraduate and graduate in person. These meet on Monday, Wednesday from 2:30 to 3:50, and we are going to meet in Life Science 102. In my MAV, for whatever reason, it put these 2 sections with me as the instructor, same day, same time in 2 different places. So I'll send out an announcement as well, just so everybody gets the message. In-person sections are going to meet in Life Science room 102. The online section is also welcome to start coming and attending the in-person classes starting January 20th. So that's basically next week. We should have no problem with space. I think Life Science 102 is big enough that anybody who wants to come attend in person is fine to do that. That said, everything in this course is available pre-recorded online. Down here, when we get to the expectations of students, you'll see in attendance. For all 3 of those sections, in-person attendance is optional. What we do in the in-person sections is basically office hours. I expect you to be watching the videos and following along, keeping up with the homework and the assignments outside of class. If you're having a problem, come to class and we will help you get through that. But I am not going to lecture during class. Don't feel like if you don't come to class, you're going to miss important content. Okay. I have a disclaimer there that if seating is limited, students in the on-campus sections will be given priority. That has to be true, but I've never had a problem where we ran out of seating. And so starting next week, regardless of which section you're in, you can come Monday, Wednesday, 2:30 to 3:50 in Life Science 102, and we will be there to help you. I and the GTAs will all be there. Expectations for out-of-class study. If you've never done coding before, it can be time-consuming. Okay, so right, if the basic math for what you expect is a 3-hour in class, then you get 9 hours out of class. I'd say that's at least your expectation. Okay, especially in the coding section again. If it's new to you, learning a language, there's no substitute for just spending time doing it. Other stuff, just be checking the course homepage, the announcements, make sure you've got your notifications turned on for the course so that when I do post an announcement, because those are usually, something changed about a module or a deadline that was unanticipated. And so you need to make sure that you're getting those announcements. And then this one's important. Keep up with the pace of the course. So I'm going to jump back over to the course schedule, which is on the main homepage, right? This is the first landing page. If you scroll down a little bit to the course schedule, this has a day by day. This is what I expect us to be doing. Okay. So you've got the modules, and you can see module 1 goes for the first 5 weeks of the class. And these are beginning bioinformatics tutorials, mainly learning Unix, learning Python. It's got the goal that I have set for the class. Ideally, right, if you're keeping up, you are finished with this goal before class time on, well, say, for example, we are doing this section. You won't know to come to class to get help with that if you haven't tried to work on it before that class period, right? So the intent is that you are done with this by the end of that class. Then in the last column here, you've got the due dates for all the assignments. So that's the quiz, right? So in the description of assignments, there was 1 quiz and then 23 homework problems. So the first quiz is due January 27th, and then the first 9 ROSALIND problems will be due on February 16th, and so on. Right? So these are, I think I made it so those are on a Sunday, if I remember right, and basically giving you the weekend after we've gotten through that part of the content. So right by this Thursday, February 12th, I expect us to have gotten through all the tutorials up to covering ROSALIND problem homework number 9. And then that homework will be due that following Sunday at midnight. Okay. And so you can see we will be doing lots of coding. This algorithm section is sort of learning to code while you learn to translate biology problems into computational problems. And then we're wrapping up the really heavily coding part of the course at spring break and moving into remote high-performance computing and applications, transcriptomics, sequence alignment, genome variant analysis, and then final projects. Final projects vary from semester to semester. Last semester, we did annotation of transposable elements, which is fine if you don't know what that means yet. This semester, probably will do something like that. There are so many new genomes coming out that are unannotated. That is a very useful skill to develop as a bioinformatician. Okay, let me go back here. So that's all keeping up with where you should be in terms of my expectation for the course schedule and keeping pace. You can expect me to be on top of my email. Like I said earlier, if it's content-related questions, I may not get to those until scheduled office hours, but certainly logistical kinds of questions, feel free to email, text, and you don't have to wait until office hours to send me a question. Just realize I may not get back to it until office hours. I'll do my best to get back as soon as I can. And same with the GTAs. All right, these next couple pages talk about technology requirements, or not couple pages, this page. For hardware and software, if you have a modern laptop, I put less than 5 years old here, but try it. If you have an older laptop, there's no harm in trying. It'll probably be fine. It doesn't matter if it's Mac or Windows. Very challenging probably to get by on a Chromebook. I have seen it work, but it's a little bit more challenging sometimes. And then certainly an iPad is probably not the way to go. So any modern laptop, Mac or Windows or Linux, Linux may be the best if you're in that mode. That's what you need for the course. This is a computer course, and if you can have your own laptop, that's the best option. UTA Libraries has laptops for checkout as well as other technology peripherals. I've given you some links there. Um, but the best is that if you have your own, partly because you're going to be developing a computational environment for coding and for navigating the HPCs. And it's just better if you can have that persist beyond the end of this course, which wouldn't be possible if you had a laptop checked out from the library. The other stuff, just basic software that hopefully all of you are pretty familiar with. Microsoft Office products, PDF reader, viewer, um, some links there to get that from the UTA resources. This course requires extensive use of your computer in a Linux or Unix environment. Now, Mac users, Mac OS is just a flavor of Linux at its heart. Windows users, there's a little bit more energy of activation. I've given you some resources here. It's gotten easier and easier. The Microsoft App Store, now you can download and install Ubuntu. If you have problems, which tends to happen on older laptops, I've given you some links to try to help work through that. But usually the first week or so of class, these are the biggest challenges. Windows users trying to get their environment set up so that they can be operational in a Linux environment. The other big piece of software that you'll want to install, and this doesn't have to be right away. We will revisit these in the different modules when we need to use them. But Anaconda, which is it's an interface for a package manager, which helps manage Python code or Python, the Python coding environment, let's say. So a link there to download that and get that running on your machine. And then finally, ROSALIND. So this is the big one. This is the first set of, when I kept mentioning ROSALIND homeworks, this is the online platform that we're going to use. It's a really fun platform. I'm not giving you all of the problems that are in ROSALIND. So it's important that you go on, register for an account using this link right here. Now, ROSALIND will ask you for a validation, and for whatever reason, UTA's email servers tend not to like those validation emails from ROSALIND. Sometimes they go to junk. I've also experienced where people just don't get them using their UTA email. So it's fine if you want to use your Gmail or if you have some other third-party email to register for your ROSALIND account. I just go by the name that's in there. I match the name up in ROSALIND with the class role that I get from MyMav. So if you have trouble, you can try your UTA email, but if that doesn't work, try an alternative non-UTA email. So once you have an account in ROSALIND, though, there's a second step. You have to enroll in this course. And so I've given you an enrollment link here. That will take you to the ROSALIND page that signs you up for this course. Once you successfully enroll, you'll get a page that looks like this. And this has the problems and the due dates for all of the ROSALIND problems that we'll be doing, that you will be responsible for. Okay. Like I said, it's a really cool system. In a nutshell, it generates data sets for you to run your code on. It gives you the problem. It tells you what kind of data you're going to be given, and then what kind of output it expects. And then you go write your code on your own time, and then come back when you're ready. You click the link, it will give you the data, you run your code, upload your answer, and then it automatically grades it for you. I think it's a really fun and really great educational tool, and there's lots there to explore once we're done with the course. So you can go a long way in bioinformatics training on that platform. Okay, this Canvas section, this is standard UTA boilerplate stuff. This is all this and the next page, student resources. Again, this is all UTA standard policies and letting you know where you can find additional resources that are campus-wide. Want to point out one other thing here on the academic integrity bit. The real world works in collaboration. I am fine with you collaborating on the homeworks and the assignments in the sense of talking to each other, helping each other with the coding problems. I think that's great. You should learn to work in teams. And the final projects for the course will be team group assignments. So that's all good. If there's an exception to that, for example, the quiz and the midterm, those are individual, right? So no collaborating on those. I'll reemphasize that when we get to that. And then the last thing here, the use of generative AI, chat GPT. For this course, unrestricted use of Gen AI. If you want to use chat GPT, go for it. I think everybody should be learning to use this. Future versions of this course will lean into this even more, I'm sure, as it just becomes more and more pervasive. Okay. The last page here, the discussion/question board. If you have questions that are general that you think would be beneficial for everyone to have answered, you can post them here, and I will try to get back to them. Occasionally, I'll also, if it's something I think it needs immediate attention, I'll also post that as an announcement. But this is a place where you can ask questions, and I or the GTAs will try to get back to you. And that's it for getting started. If you click next, it will take you to the first page of module 1. Rather than just go through that, I'm going to jump back to the modules page just so you can see that all of the modules after getting started are laid out basically the same way. There's an at-a-glance page, which gives you an overview. It's a very brief video that just says, what are we going to do this chapter or this module? And then it describes the assignments for that module, just basically as a checklist. The real meat of every module is in this read and learn section, and the pages are called videos and media. And so you can see for module 1, right, we're going to spend a long time on module 1, but that's because there are quite a few videos. You can think of each of these videos as a day of class. So most of these are an hour or more. And one of the real benefits to doing this class in this format where I have everything pre-recorded is that lots of these are tutorials where you're actually doing hands-on coding. These aren't just me lecturing. And so when something you try to code doesn't go well, on a pre-recorded video, you can just pause it, work on it until you're able to do it successfully, and then pick up the video. It's a way more efficient way to do it than the old style of me trying to keep a whole class on task at the same rate. Because what ended up happening in that sort of modality is that, some people it would work and some people it wouldn't. And then I would be constantly frustrated with, do I move along to help the people who are already completed, or do I stop and wait? And so some people are twiddling their thumbs and some people are frustrated because it won't work. All of that gets avoided with these pre-recorded lectures. So keep up what I was saying before with the course schedule. Each of these is on that master schedule as a day in the schedule, so you know which videos you should have watched by any given day. There are the PowerPoints that go along with those. And this is just the standard format for the whole course. So that videos and media page is where the bulk of the content is in every section, right? So you can see module 2, same layout. You've got that overview page, videos and media page, go there. It's got the lectures, it's got the PowerPoints. And then as you're going through the modules, you've also got the assignments there. So if you were to hit the next button from the videos and media page, it would take you to the first assignment for that module. Okay. All right. So that's it for this intro video. Hopefully that's enough to get you going. I enjoyed teaching the class. Look forward to meeting all of you, and hope you have a great semester.